Hi everyone. So we're back. We're back, and so yesterday or last week we talked about just the code to basically join the Snowtail data. Well, first to recap, we have combined the data, kind of the data from Snowtail with the data from the river flows and the weather stations. So that has been kind of combined into a data frame. And then the data from the Snowtail has been combined with that. And then where there isn't, they're basically a bunch of nans because the data only comes in every 24 hours. So now what we need to do is we need to try to fill those nans, I guess, with an average, probably an average of the values of this. It could either be like the average of the two of the time stamp before and the time stamp after, or it could just be the previous time step. I mean, there are different ways of doing it, but you could also do something like, I don't know, the difference of the two, and then like slowly divide that by the number of hours. I mean, we don't really know how much the snow is melting over the course of the day, except that and what times it's melting. Except we do know that it's melting during the day. So yeah, we're gonna talk about that, and then we're going to then also look at potential other sources for the additional weather stations for the stream data. And yeah, those are the kind of main things and stuff. So yeah, let's keep doing that. So we'll just run for this again. Basically, this code is should be working fine from last week, because we did get it to join okay, and then yeah, we'll see from there how we'll exactly fill these kinds of like missing values. Another thing you could potentially do too is like leave these missing, and then what the end user, in this case whoever's a data scientist, is using this is something you might actually do that if you were, say, in like if you were actually working in, say, data engineering. You would maybe just leave it for your data science team to decide how to handle the different spaced values. But here I'm really trying to create an end-to-end data set for someone using the paper. So I'm not going to... so I am going to maybe... I might leave this column, but then I might create another column called filled, and then we write to the table, then people can still see which values were originally filled and which were null. But the idea of this too is I want people using the data set to be able to use it right out of the kind of box, I guess. So yeah, so we did combine with Snowtail. So we're just gonna get this as like as this kind of here. That's not what I wanted. And then, and what's going to happen is we're going to then, so combine snowtail df, and then I don't know why this was here actually. And then what we're going to do is I have to remember how to do this in pandas. With median to closest. So this is kind of what we want. So basically, yeah, here he's saying, so yeah, replace with the mean of the non-nearest, free non-nearest empty values. Five, 18. Okay, so here he says combine rolling with mean with another rolling from back. So that kind of is what I want. So that's like the rolling of free, and then you take the mean, I guess. So I guess that could work. So yeah, actually I might just do this. So it looks like for this, rolling free. Okay, so we'll just look at this now and then see if this makes sense, I guess. So he's doing it with free. I don't know. So the free closest. Well, so these are in 24-hour intervals. So basically we know it's always going to be 24. My guess is, yeah. So actually, my guess is if we applied this code to this, we'd actually still have a lot of NAs. Because, so yeah, because, yeah, we're doing it over that but let's see, so we'll take snow depth in inches. I don't really actually like these column names too, so I might definitely change them in the final thing. But let's just try that. Okay, yeah, I think that needs this here. Oops. We didn't have the outside brackets. Okay, so... So I think this should work, but I'm not sure, so... Well, it will do what they were saying there, but I don't think that's going to work. Because... Oh, yeah. These are spaced 24 hours, so my guess is I'll need to move the rolling to combined snowtel df. That's what I need. There we go. Let's look at what C is then. Okay, but what about like in January? So let's look at okay, well I'll look at this, I guess, in I'll actually make this a column. Combined snowtel df filled snow. Cause yeah, the thing is that here, I mean, actually, it's not wrong to have really NaN values here. Just then, if you want to like pass those values into, say, a machine learning model, then it's gonna cause problems. So, so yeah, this is, I guess it's more like data science here, kind of. But at the same time, okay, I want to. Oh yeah, I want to scroll through this. So what? Like if we did 100 days, that would begin to put us in winter, I think. What? That should be putting us... Oh, yeah, I know. We need something like 100 times 24. Which is like... That should get us a bit closer to winter, right? And this goes to like 2,500 or something. Okay. Okay, so that actually did generate filled values. So I think that basically means it's summing. It's getting the rolling of the free closest filled values, I guess, is what it should be doing. So, okay, I'm going to convert this to this and convert it to an interactive table or whatever. So then I can see. Wait, where'd the fill to go? Oh, shit. Wait, why don't I see it all of a sudden? I suddenly don't see that row. For some reason. Oh, because it's limiting to the first 20. That's a pain. Okay, that's not what I wanted. I'll just rerun that then. Filled snow. No, I don't want to do that. I want to see, like, I don't want this truncated, though. I want to see essentially 24. Okay. Oh, shit. Wait, then why didn't that fail? Lol. Okay, let's see. Oh, there it is. Yeah, this is... Okay, I'm just gonna slice, actually, maybe 12,700 to 12,724. See if I can see this. Okay, so it's 7 here. So it's 7 there. Yeah, I think it's basically just going with the previous value then, it looks like. Let's try. Yeah, it looks like, and then when it sees the new one, it just lists that all the way until the next day, which I guess works. Yeah, so it basically just keeps that filled until it sees the next one, which wasn't exactly, I think, what I originally wanted to do. You did a rolling mean, though, of, say, like, 25. I don't think that would happen, right? Yeah, let's see what that looks like, if it's actually more of an average. Let's try that. So here the real value was 7. Well, I don't see where the actual mean is coming from. Seems to just be filling. Yeah. I mean, if you just did A, maybe you'd see that. I don't actually. Because here it's saying then again it's like that. So, let me see. Just change anything. Oh, interesting. Now these are all nan, actually. Okay. It's probably not something what I wanted. Let's see. Well, it looks like A is coming out to nan. And then, so yeah, I mean, I do think you need to see that. I'm just not sure how these are actually affecting it. It seems to just move at the point with this one. I mean, this is essentially saying compute the rolling mean over 25. This is saying compute the rolling mean in the other direction. Then fill. I'm going to go back to what he says. So that does work. Oh. Of the three nearest non-empty values. Nan at index 4. Okay. Oh wait, interesting. Yeah, he does fill in a on one, but then not the other. So but yeah, it doesn't seem to be making much difference changing the rolling though. Yeah, I mean, okay. In any case, that does kind of work, but I'm gonna kind of document this just quickly. Yeah, I think the best. I mean, it would be fine, I think, too, to just do it this way, but I mean, let's think about what we want to do, too. The basic problem is that the snow tell is reported every 24 hours, whereas this other data is reported hourly. So the question is what to fill this other 23 time steps with per day, each day. Should it be just the first value? Or actually, yeah, that's another thing. Actually, maybe that value makes sense because the thing is too, when we go to forecast, we don't actually want to have, we can't incorporate future data. So maybe just up until the next time step, this would actually. So yeah, actually, this I think is uh could just work this way. Because, yeah, actually, if you think about it, this is probably what we want. Anyways, um, though I guess there should be a simpler way of doing that. But in any case, yeah, because you, obviously, when we forecast, we're only going to get up to that current day. So, yeah, so we should just use that to fill it, I think. So that's what I would do probably. Um. Okay, so yeah, let's just leave it like that. But I'm guessing there is a simpler way of doing that. Because now it looks like it's doing a bunch of things at once. Um. The thing here too is I don't know like what would happen if you just did like combine snow depth, interpolate, fill. Um. Like this, like I don't see how that's much different than that. Like if you just did this. Like say we called that C. Um Yeah, I mean, it's producing the same thing. So I really don't know what this, all this other stuff doesn't seem to be coming into play in this one at least. I'm gonna blank that out. There might be a time where we have another idea and this becomes useful. So I'm just gonna comment out for now, but and then what we can do is we can just bring this up here. There it will hopefully still work. So yeah, so basically this we might actually want to put into this function, like for the final code. So okay, so that's kind of the core of that. But that will kind of get it, and then fill, I think one of the other things to do beyond that is to try to start the process of thinking about how we're going to get better, closer precipitation data, because there was an issue with a lot of things, as I said, where the actual precipitation is pretty far from the the ASOS weather station is pretty far from the essentially the USGS gauge. So I did figure out how to request reports from NOAA for. Oh yeah, and the other thing about the NOAA stuff is then you can also get the snow depth for some of the eastern places. So apparently some of these these stations have them, these sorts of stations. Like this one, for instance. I don't know what is in Kucheras. But basically in the FlowDB 1.0, all the weather data was taken from ASOS, which is that air surface. It's the big network, but particularly in some other states there are other networks which I think could help supplement it. And then the other thing I was thinking too, and this gets into how we'll eventually think about creating the schema and everything in BigQuery, is how to how many weather stations to pull in on one combined table, so but yeah, that's something to think about probably another day. So so yeah, we'll keep this episode short. I know not a lot of progress here, but we did figure out how to fill in some of the snow data. And we'll have to do this with some other files too. In terms of I think adding more data. Oh, we also want to look at scan, which is apparently this soil moisture data. And it's available using these, again, we're using these report generators, but I'm not exactly sure how to call these as an API. So it does say, like, in these scan data that, like, the moisture at different percents and stuff. You can, oh, you can generate a CSV from this. So maybe like you could do so yeah, we'll need to write code that calls this API. That is if there's none on GitHub already. This is from USDA. So, but in any case, scan is something else. We'll have to use. So, in the end, where the heck did that thing go? And go open existing. Oh, there we go. So yeah, in the end, we are going to have this SNOTEL data, ASOS, then probably another set of weather stations we'll call for the API for. Then we're going to have scan, and then finally we're going to have the satellite imagery data, which will come from like Sentinel. But luckily, that's actually already apparently on BigQuery. Well, not BigQuery, but in a GCS bucket. And it actually even has its own pub subtopic. So, but either way, we'll basically subscribe to that too, and ingest it, and yeah, then that will be kind of the combined data set, the weather station data, the gauge, flow data, the snowpack data, the soil moisture data, and then the satellite imagery. And that's going to be what creates kind of our multimodality data set that can then be used for forecasting all those cool things. So yeah, so that's it for today. I think we'll definitely have a longer video tomorrow. And yeah, tomorrow I think we'll actually work on getting some of the metadata into its own BigQuery table, where it's easier to query the metadata. So we can work on that. So okay. So yeah, we'll end there for today, and we'll